Hi, my name is Ashley Hale, and today we are going to be solving a chemistry problem from the area of stoichiometry. Today our problem is iron is exposed to water and rusts to form iron oxide and hydrogen gas. If I had a 450 gram sample of iron, how many grams of rust, which is iron oxide, should I be able to produce? So, our first step is to find the skeleton equation. Our skeleton equation is going to be Fe, which is a solid and represents iron, reacts with H2O, which is water and is a liquid, reacts to produce Fe2O3, which is our iron oxide and is a solid, and also produces hydrogen gas, which is represented as H2, and that is because when hydrogen is represented by itself, there is two. It comes in a pair. That's important to have for when you're balancing your equation. Now, what we want to do is balance the equation, and to do so, we're going to balance the elements, each element, on the side of reactants and on the side of products. So, first we're going to count up how many we have on each side. On the left side, which is our reactants, we have 1 iron, 2 hydrogens, and 1 oxygen. We also have on our right side, on the products, we have 2 iron, 3 oxygen, and 2 hydrogen. So, to start our balancing, we are going to add a 2 on this side in front of our iron to balance out the 2 that is on the other side. That is now balanced. Next, we need to balance out our oxygens. So to do so, we are going to add a 3 in front of the H2O. That leaves us with 3 oxygens on the left side, but it now leaves us with 6 hydrogens on the left side. So to fix that, we are going to add a 3 in front of our hydrogen gas on the right side to also give us 6, and then our equation is balanced. Next, what we want to do is find all of our molar masses. So to start, I'm going to find the molar mass of each individual element, which can be found in the periodic table. Iron is 55.85 grams. Hydrogen is 1.008 grams, and oxygen is 16.00 grams. That is important to have both zeros for when you're using significant figures later on, so make sure you include both zeros. Now we want to find the molar mass of our 2 compounds. 3 compounds, actually, because we have H2, so we need to add that up as well. So H2O, what you'll do is you'll take the amount of 2 hydrogens, which is 2.016, and add that to the 16.00 grams that can be found in oxygen, and that will give you 18.016 grams. So that is our total for H2O. Now for iron oxide, we will add up 2 irons and 3 oxygens, which will give us 159.7 grams. Now, we also want to take the molar mass of H2, and H2 is 2.016. So those are all of our molar masses. Now we want to start solving our problem. To start, we want to start with our given. Our given can be found in the equation, and it's 450 grams of iron. And we're going to end with grams of iron oxide. or rust, if you will. So, to start, we're going to start with our given in our equation, which is 450 grams of iron. And we want to switch that to moles so that we can switch from one substance to another, because you can only switch from one substance to another if you are in moles. So, to do so, we are going to use our molar masses, which we got from the periodic table. So, our molar mass of iron is 55.85 grams of iron. Don't forget your element or compound in your units. And that is equivalent to 1 mole of iron. Now, using a molar ratio, which is found in the balanced equation, we are going to convert from moles of iron to moles of iron 3 oxide. So, we have moles of iron on the bottom because we want that to cancel out the moles of iron on the top. And on this top half, we're going to have moles of iron 3 oxide. So, in the balanced equation, we want to look and see how many there are of each. So here we see that there are 2 moles of iron. And we see that there is 1 mole of iron 3 oxide. So that is our molar ratio. Now we want to convert from moles of iron 3 oxide to grams of iron 3 oxide, which is our endpoint. So, to do so, we have 1 mole of iron 3 oxide, because we're going to make it equivalent to however many grams there are, which is going to be 159.7 grams of iron 3 oxide. Now, the best way to put this into your calculator is to multiply the top row together and then multiply the bottom row together and then divide them as with those 2 values. So our top row will give us 71865, and our bottom row will end up being 111.7. Now, when you divide those 2 in your calculator, you will get a large number. It will be 643.375, and so on and so forth. But we need to remember our significant figures. So, for your significant figures, you'll use the however many you can find in your given. So in our given, we have 3 significant figures. So we want to cut our end result down to only 3 significant figures. Now here, there are 6. So we're going to take these out, and we'll be left with 643. You're not going to round up because our decimal is not above 0.5. Not 0.5 or above. So our answer is 643. But then we need our units, which is grams of iron 3 oxide. Now to double check that this works, we're going to go through and cancel everything. So first we want to cancel from grams of iron. We want to cancel out our grams of iron. So here, it's canceled out here and there. So now grams of iron is gone, and we are in moles of iron. And you can see that is canceled out here and here. So that's canceled out. And now we want to cancel out moles of iron 3 oxide. And we do so right there. And we are left with our ending point, grams of iron 3 oxide, which is the unit that our final answer is in. And that is why our answer is 643 grams of iron 3 oxide. Thank you guys for watching.